Kia ora Year 12. This is the third video I'm doing on implicit differentiation, the second one this afternoon. This is a slightly harder example from Dr. Frost, and it's one where you first have to find the derivative, but then you have to use that derivative, and you have to find the gradient at a particular place. Okay, and the place here is where x equals 1. So first, as usual, let's have a quick look at the graph of this. So this is my relation between x and y, and it's quite a cool one again. And this time, what I want you to visualize is that we're looking for the gradient where x equals 1. So we're going to have to figure out what the y value is where x equals 1, because my expression for the derivative will have a whole lot of x's and y's in it. Right? So we need to work out what that is. So let's start off by differentiating. Now there are a couple of ways that you can do this problem. But I want to get some work happening on the chain rule. So one option is that we could expand this out here. And that's probably the safe way to go when you're just starting out, right? So we could do x squared plus 2xy plus y squared equals xy squared. Alright, and then we could go term by term there. But I'm not going to do that. I'm going to leave that x plus y together in the bracket and show you how nice implicit really is. So what I'm doing here is I'm differentiating this with respect to x. So it's going to be 2 times x plus y to the power of 1. Right, so that's just the polynomial rule, the very first one we learnt, times the derivative of the inside function with respect to x. So that's going to be 1 plus dy by dx. And then on this side I've got the product rule to work with. So I'm going to have x times 2y dy by dx plus y squared times 1. So let's clean all of that up. What I'm going to do is get all of the terms with dy by dx together. So that's going to give me dy by dx times 2x plus y minus 2xy, right, so that's from this side here, equals y squared minus 2x plus y. All I'm doing there is I'm just rearranging, right? So anything that's got a dy by dx in it stays on the left hand side and vice versa. You don't have to do it that way, it's just one way that you can do it. And now what are we going to get? Well, dy by dx will be y squared minus 2 times x plus y over 2 into x plus y minus xy. Now, you don't have to do even that much cleaning up, because we know from the question that all we're going to do is to try and figure out what is dy by dx when x is equal to 1. So we can see that we're going to substitute 1 wherever x is, but what is my y value going to be? So what we have to do now is we have to go all the way back to the start and say, well, x plus y squared is equal to xy squared. So if we substitute in x equals 1, we get this, 1 plus y squared is equal to y squared. Expanding the left hand side gives me 1 plus 2y plus y squared is equal to y squared, leaving me with 1 plus 2y is 0, so y is equal to negative 1/2. So that tells me that the point on the curve that I'm interested in has got coordinates 1 and negative 1/2. And now all I have to do is to take those coordinates and plonk them up here into this expression. But I'm just going to write it out nicely down here, because it's very easy to muck these up. So we've got y squared minus 2 times x plus y over this. Right, so you should pause the video and have a go at that before you watch me doing it. So here we're going to get 1/4 minus 2, 1 minus 1/2 over 2 times 1 minus 1/2 minus 1 times negative 1/2. So it's very easy to go wrong whether you're using a calculator or not. So in the numerator we've got 1/4 minus 2 times 1/2, and here we've got 2 times 1 minus 1/2 plus 1/2. So that's nice, so it's just 2 times 1. Right, so 1/4 minus 1 is negative 3/4 over 2, giving me a final answer of negative 3/8. Now, just quickly before you disappear from the video, I want to go back and show you that that makes sense with our graph. Okay, so we've found the gradient, and if you look at the graph, you can see that the y value of -1/2 looks perfect. So here it is here, and the gradient of that line of -3/8 also looks good. So a question might go on quite a long way from here, right? It might ask you to find the equation of the tangent, or the equation of a normal, or it might have some other curve up here, and you then had to find the intersection, right? But the main thing that you've hopefully learnt from this is, first of all, how to find the derivative, and then the new thing in this video was how to get the coordinates when you're just given one of them. Alright, thanks for watching. That's all for now. Make sure you can confidently do the Dr. Frost work that I've set.